Hi everyone, this is K Anand Goud, Assistant Professor, Civil Engineering Department, Institute of Aeronautical Engineering. So today I am going to discuss about the topic ceramics and refractories. Okay. So coming to the definition of ceramics here, it is a inorganic non-metallic materials. Okay. So it is a inorganic non-metallic solid made up of either metal or non-metals. Okay. So inorganic means here it is not going to react with the other materials when you add or when you mix with other materials. So when you prepare any material with inorganic non-metallic solid, okay, that may be with metals or non-metals. Okay, it may have the metal compounds or it may don't have the non-metal compounds also. Okay, so that have been shaped. Okay, after collecting this material, metals or non-metal compounds, so it is going to we are going to make the particular clay, okay, or its material into the shape, and then we are going to heat the particular material. Okay, so here it have been shaped and then hardened by heating to high temperatures. Okay, it is not going to shape and hardened in a normal temperature, but we are going to make the particular materials in a very high temperatures. Okay, by heating the particular material, we are going to get the hardening of these particular materials. So here ceramics are nothing but it is inorganic material or else non-metallic solids, okay, which are made up of with the metal compounds or non-metallic compounds, and after making into definite shape, we are going to heat the particular materials or else ceramics at high temperature, very high temperatures. Okay, so that is what the ceramics means. And here in general they are hard and corrosion resistant and brittle. Okay, hard is nothing but they are going to take some loads, some extra loads. Okay, and resistance to scratching. If you apply any scratches or else any indentations, if you make any indentations on the material, it is not going to take, it is going to resist. Okay, so next, corrosion resistance. There is no formation of corrosion for this particular ceramic materials. Okay, and next, brittle is nothing but it is going to fail when you, suddenly it is going to fail suddenly. Okay, without any deformations. Okay, without any elastic deformations, suddenly they are going to break. Okay, so these are the main properties of ceramic materials, and here in this picture you can observe some of the ceramic materials. Okay, visuals. Okay, so here coming to the next one, traditional ceramics are clay based. Okay, initially in olden days they have made this particular ceramics by using clay based materials only. Okay, so but high performance or advanced ceramics are being developed. Okay, nowadays we are developing very advanced ceramics which contains inorganic and non-metal materials. Okay, so in this particular advanced ceramics, we are going to have inorganic non-metal materials. Okay, by using these particular materials, we are going to develop some advanced ceramic materials. Okay, compared to olden days clay-based ceramic materials. Okay, when you compare clay-based ceramics and these advanced ceramics, the strength will be varies. Okay, both in between these two materials. Okay, so here advanced ceramics have properties of, okay, here we have some advanced ceramics, and these particular ceramics will have following properties. Okay, here high strength. Okay, so this is with the comparison of clay based ceramics. Okay, just remember that point. When you compare the old and traditional ceramics like clay based ceramics, these are some of the advantages. Okay, in advanced ceramics. So first one is high strength. Okay, it will be having high strength, and next, high hardness. So hardness is nothing but resistance to scratching. Okay, if you make any scratch, if you make any indentation on that particular material, so it is not, we are not going to get any indentation, any dips over the ceramic materials, but it is going to resist. Okay, that is what here it represents high hardness. That means resistance to indentation or else scratching. Okay, and high durability. That means here durability is nothing but the service of this particular materials will be longer period. Okay, when you compare with the clay based materials, this particular ceramics, advanced ceramics, will have the service period more than this traditional ceramics. Okay, and next, high toughness. Okay, toughness is nothing but here it is going to absorb some energy. If you apply some forces on the material also, it is going to take some energy. Okay, that is what here the toughness means. So it is having high toughness, high durability, high hardness, and high strength when you compare with the normal traditional clay based ceramics. Okay, so here ceramic comes from the Greek word. Okay, meaning like it is a Greek word, and the ceramic means it is a pottery. Okay, pottery is nothing but it is a meaning of ceramic, which is a Greek word. Okay, and the clay-based domestic wares and art objects and building products are familiar to all of us, but pottery is just one part of the ceramic world. Okay, so when you go with the clay-based domestic wares, like you can see the some of the art objects also. Okay, or some building products. But here, whenever you are going to listen about the clay-based materials, here we are going to get the pottery. Okay, pottery is also one of the clay-based products. Okay, and next, nowadays the term ceramic has a more expansive meaning. Okay, more expansive meaning is nothing but here we are going to add some other extra materials and we are improving the properties of ceramics. So that is why the meaning of this particular ceramic has changed. Okay, so and includes materials like glass, advanced ceramics, and some cement systems as well. So in this particular, why this particular ceramic meaning changed? Because here we are using some advanced materials like glass materials, okay, or some other cementitious materials in the manufacturing of ceramic based materials. Okay, so that is why the term is changing the properties here. Okay, and next, contains oxides like alumina. Okay, in this particular advanced ceramics we are having the oxides like alumina also. Okay, we are adding alumina based oxides also to prepare the advanced ceramics. Okay, so non-oxides are often carbides. Okay, here we are going to use non-oxides also, that is carbides, borides, nitrides, silicides. Okay, for example, if you take boron carbide, okay, boron carbide is also one of the carbides, and silicon carbide. Okay, and next, molybdenum, disilicide. Okay, so these are the some of the minerals we are adding. Okay, these are called as a non-oxides. Okay, so these non-oxides are added in the manufacturing of ceramic materials. Okay, just remember these chemicals. And next, coming to the properties of ceramics. Okay, these are the common properties. Okay, so the first one is high melting point. Okay, so the melting point is high. That means the resistance to heat will be very high. Okay, so they are heat resistant. High melting point is nothing but they are going to resist more heat. Okay, we can apply very high temperatures also for this particular ceramics. And next, great hardness and strength. Okay, as we have discussed already, strength and hardness is also very high for ceramic materials. And next, considerable durability. Okay, that means the service life. Okay, they are long lasting and hard wearing. That means the if you apply just some external forces also, it can bear that loads. Okay, without any damages, without getting any damages or failures, it can give service to the users. Okay, that is what the durability here. And next, low electrical and thermal conductivity. Okay, that means they are good insulators. Okay, and next one, chemical inertness. That means it is not going to react with the other chemicals. Okay, it is an inert material which is not going to react with the other chemicals. Okay, they are unreactive with the other chemicals. Okay, these are the some of the properties of ceramics. Okay, and next, coming to the mechanical properties. Okay, first one is tensile strength. Okay, here we don't need to discuss about this particular topic clearly, but I'll tell you the properties. Okay, so here first one is tensile strength. That means if you apply any force on the member which is moving outwards, okay, which is moving away from the object, then it is called as a tensile strength. So these are having high tensile strength also. Okay, high tensile strength. And next one, compressive strength. So the compressive strength is also very high compared to other properties. And shear strength. Okay, so these are the some of the mechanical properties which we are going to observe in the ceramic materials. Okay, and next, coming to the classification of ceramics. Here, based on their internal structure, the ceramics are classified as first one, clay products. Okay, based upon the internal structure between the particles, it is classified as a clay products. Okay, and refractories and glass. Okay, so these are the different types of ceramics. Okay, so depending upon the temperature also, we are going to divide these particular ceramics. Okay, the first one, clay products and refractories and glasses. So in this particular session, we are going to discuss about refractories. Okay, majorly. So coming to the refractories. So what do you mean by refractory? So refractory is a material that withstand high temperatures without undergoing any deformation. That means when you apply high temperatures, any material is going to get deformation. Like every material is having some limit for temperatures, right? So this particular refractories can take around 2000 degrees Celsius also. Okay, more than 2000 degrees Celsius also they can take without damaging the materials. Okay, that is what the definition here. Okay, it is a material that withstand high temperature without undergoing any deformation. It means we are not going to get any sagging or else any failures in the material. Okay, if you apply more, high temperatures also. Okay, and it may be shaped or unshaped. Okay, the shape of the refractors we can change or we can use directly into a definite shape also. Okay, and coming to the classification of refractories. Okay, so here based on the chemical behavior, how they are going to behave when you apply different chemicals or else when you apply different temperatures. Okay, the first one is acidic refractories. Okay, so when you use these particular types of refractories, these are going to combine readily with bases. Okay, whenever you are using these acidic refractories, these refractories are going to react with the bases like silicon dioxide. Okay, if you take an example of base SiO2, so it is going to react. Acidic refractories. Silicon dioxide is one of the acidic refractory, and it is going to react with the bases. Okay, directly. And next one, second one is basic refractories. Okay, consist mainly basic oxides. Okay, it is going to react with only oxide acids. Okay, so combines mainly of basic oxides. That is examples of basic refractories are dolomite and magnesium oxide. Okay, so these are the few chemicals which we are using as a basic refractories, and these are going to react with the. These are going to have basic oxides as a main ingredient. Okay, and next one, neutral refractories. Neutral refractories are nothing but these are going to react with the acids and bases combinedly. Okay, so initially acidic refractories are going to react with the bases and basic refractories are going to with the acids, but here these neutral refractories are going to react with the both acids and bases. Okay, so the examples are Cr2O3, chromium trioxide and carbon. Okay, and highly pure aluminum trioxide. Okay, aluminum compounds also they are going to react with the both chemicals. Okay, like acids and bases. Okay, so these are the classification of refractories based upon the chemical behavior. Okay, next one based on use. Okay, based upon the usage of the refractories, where we are going to use, how we are going to use. Okay, so first one is siliceous refractories. Okay, siliceous refractories are going to containing the not less than 93% of SiO2. Okay, these siliceous refractories are going to contain silicon dioxide chemical more than 93%, but that means here we have to maintain the silica percentage around 93% in that particular material. Okay, and these particular siliceous refractories are used for roof constructions. Okay, and like next one, metallurgical furnaces. Okay, furnaces like for burning some materials. Okay, we are going to make some furnaces, right? So for the particular outer wall, for preparation of those outer walls, furnaces outer walls, we are going to use this siliceous refractories. Okay, and next, glass tanks. Okay, so for preparing glass tanks, furnaces and roofs. Okay, for these three purposes we are going to use siliceous refractories. Okay, so this is based upon the usage. Okay, we are using in roof construction, furnace construction and tanks construction. Okay, that is why this is classified into siliceous material, because this is used based upon the silica content. Okay, the next one, this is an acid refractory made from hard dense quartzite and sandstone. Okay, this is very hard material which is made up of using quartzite stone and sandstone. Okay, these are the stones which we are going to use for the preparation of siliceous refractories. Okay, and coming to the second classification based on use, aluminosilicate refractories. Okay, so this is the second classification, and this will contain silica over 65%. Okay, earlier we have discussed about siliceous refractories that is having 93%. Okay, it should not have less than 93% of silica content, right? So here in this aluminosilica refractories, here we have more than 65% of silica content. Okay, and here chamote is nothing but one of the types of clays which we are going to use in the art galleries preparation. Okay, chamote with 30 to 45 percentage of alumina. Okay, so in this particular alumo-silica refractories, it is having silica content around 65 percentage. Okay, more than 65 percentage, and then along with silica, we are also having chamote. Okay, chamote is nothing but it is one of the types of clay. I mean, calcined clay. Okay, calcined clay, which is having the proportions of 30 to 45 percentage. Okay, this chamote proportion is around 30 to 45 percentage of alumina. Okay, whatever the total alumina we are using, around that we are using 30 to 45 percentage of alumina are used in brickwork. Okay, here these particular alumo-silica refractories we are going to use in brickwork and lining of furnaces. Okay, so we are making furnaces in the by using siliceous refractories, right? So to line the outer to prepare the outer surface, we are going to use alumo-silica refractories, and in brickwork also we are going to use this particular refractories. Okay, which can withstand the high temperatures. Okay, next, aluminum silicate items are used to line cupolas and coke ovens. Okay, cupolas are nothing but, so these are the cupolas on the houses. Okay, in the houses we are going to make some dome shaped structure. Okay, so this is called as a cupola. Okay, for lining these cupolas or else for construction of these particular cupolas and coke ovens. Okay, for preparation of coke we are going to use some ovens, right? So to prepare that ovens also we are going to use this alumo-silica refractories. Okay, and next, coming to the refractories, magnesium refractories. Next category is magnesium. So consists chiefly of magnesium oxide around 80 to 85 percentage. Okay, depending upon the chemical composition we are going to classify, right? So here magnesium refractories are nothing but here the magnesium oxide content will be around 80 to 85 percentage. Okay, and their refractoriness may be as high as 2000 degrees Celsius. Okay, so here the refractoriness is nothing but resistance to heating. Okay, so resistance to heating without getting any deformation. So these particular magnesium refractories are going to take around 2000 degrees Celsius heat also. Okay, so without getting any failures. Okay, and next, Chromos it is an important basic refractory. So earlier we have discussed about the basic refractories, right? So in that particular basic refractories, this magnesium refractory is one of the major refractories. Okay, which we are going to use as a basic refractory. Okay, and next, coming to the next one, Chromos refractories. Chromos refractories are nothing but obtained from chromous iron. Okay, it is also obtained from the iron, but at different but varying temperatures we are going to collect different temperatures. So this will be having the resistance like refractoriness around 1800 to 2000 degrees Celsius. Okay, the refractoriness of chromous refractories is around 1800 to 2000 degrees Celsius. Okay, so this particular chromous iron, whatever the chromous iron we are getting this chromous refractories are blended with magnesia and alumina. Okay, so this particular chromous iron is used, and this is going to mix it with the magnesia and alumina. Okay, by mixing this magnesia and alumina, we are getting this chromous refractories, and the refractoriness is around 1800 to 2000 degrees Celsius. Okay, and they withstand attack by iron ore slags. Okay, so they are also going to resist, or else they are also going to bear the attack which is coming from the iron ore slags. Okay, and next, they are used in steel making furnaces. Okay, so whenever you are going to manufacture steel items, okay, steel products, there we are going to use some furnaces. Okay, to prepare that furnaces we are going to use this chromos refractories. Okay, and next, carbonaceous refractories. Okay, next type of refractories are carbonaceous refractories, and these are manufactured from graphite or coke. Okay, by using graphite or coke we are going to manufacture this carbonaceous refractories, and these have refractoriness above 1700 degrees Celsius. Okay, so the refractoriness, or else the resistance, the temperature is around 1700 degrees Celsius, and these are resistant to molten slags. That means from volcanoes we are getting some molten slags, right? So from that slags also they are going to resist. Okay, the resistance of this particular carbonaceous materials are very high to the molten slags. Okay, this is all about different types of refractories. Okay, and coming to the properties of refractories, here the first property is refractories are capable of withstanding high temperatures. Okay, as we have already know that. So compared to ceramics, these refractories are going to bear more temperature. Okay, high temperatures. Okay, so these are withstanding high temperatures and thermal shocks and rough usage. Okay, we can use very roughly. Okay, and next thermal shocks also it can bear. Okay, like temperature variations, if you have any temperature variations also, then it can bear or it can resist safely. Okay, and the temperatures also very high. Okay, and next one, the expansion and contraction of these materials is minimum. Okay, so if you apply high temperatures also, the expansion and contraction is very less compared to very other materials like ceramics. Okay, and next, they are chemically inactive at high temperatures and are resistant to the fluxing action of slags and corrosive action of gases. Okay, so chemically inactive at high temperatures. Okay, if you apply, suppose if you take any other materials, if you apply more temperature, then it is going to react, and that means they are chemically active at high temperatures. But these particular refractories are inactive. That means it is not going to change, it is not going to melt at high temperatures also. Okay, and these are resistant to fluxing action of slags. Okay, and next, corrosive action of gases. Okay, if you apply any gases also, it is not going to get corrosion. Okay, and next, refractories are good thermal insulators and have low electrical conductivity. Okay, the thermal insulation is also very high for refractories, and electric conductivity is also somewhat low compared to other materials. Okay, so these are the some of the properties of refractories. Okay, first one is it can withstand high temperatures, and next, thermal shocks also it can resist thermal shocks also, and the usage also very rough. We can use this particular refractories very roughly. That means in high load conditions also we can use. Okay, and expansion and contraction is very less. Okay, and next, chemically inactive at high temperatures. Okay, that is a next property, and resistance to corrosion action of gases. Okay, if you have any gases also, it can resist the particular corrosion attack. Okay, next, these are having good thermal conductivity and low electric conductivity. Okay, so these are some of the main properties of refractories. Okay, so because of these refractories, we are going to use these particular refractories in a construction depending upon the functions. Okay, so this is about your current session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.